Hello. In this video, we'll be covering the basic building blocks of financial decision makings through the time value of money formulas. When we make our financial decisions, we want to buy low and sell high. But the question is, how do we know what is low and what is high? Well, as Warren Buffett says, price is what you pay and value is what you get. So as long as the price you pay is lower than the value of what you receive, you got a pretty good deal. Or, when you go to a 7-Eleven, you buy a bottle of water for 10 baht. You're willing to pay because you put a higher value on that bottle of water than the 10 baht you're paying. But the question is, for financial decision makings, how do we place value on things? Well, in finance, we're going to be valuing things based on profits and cash flow, but that's for later. It doesn't change the fact that we invest today for the benefits in the future. So we're going to need a way to compare the costs and benefits that we make at different points in time so that we can come to our financial decisions. Is this worth the investment cost or not? Now, let me ask you this. Okay, what's worth more to you, 1 million baht today or 1 million baht next year? The answer is easy, right? Most of you, hopefully all of you, would choose 1 million baht today. Because after all, if I have to wait 1 year, why should I wait to take the same amount of money? Let's have it now. Now, if I pitch a different question to you, how about 1 million baht today versus 1.2 million baht next year? The answer may not be very clear anymore because for some of you, you may be willing to wait. For others, you would rather have the 1 million today because that 1 million means a lot for you. So we have to come up with a framework of how to make this investment decision. Now, you need one more information, right? What is that money to me? Well, one approach is to talk about future value. Now, if that money given to you, you can make use of it and you have a rate of return of 10% of your money, well, then your 1 million baht today, you can turn that into 1.1 million baht 1 year from now. And that 1.1 million baht 1 year from now is called the future value. We can take a similar approach but flip the answer the other way around. If I told you you're going to have 1.2 million baht next year, you could ask, how much do I have to have today in order to finish with 1.2 million baht next year? You can set up this equation, right? For every 1 baht increases in value by 1.1 times. So how much do I need to have today in order to end up with 1.2 million baht 1 year from now? And this simple mathematical formula shows you need to have about 1.09 million baht. And that's the present value, which asks how much money and that's the present value, which asks how much your money in the future will be worth today. And that's the basic relationships of finance. You need to have a basis for comparison, and benefits that occur at different points in time need to be processed in order for you to compare the numbers. And that's the basic premise of time value of money. Numbers. And that's the basic premise of time value of money. Benefits today and benefits in the future occur at different points in time, so you have to move them to a same point in time before you can make any comparison. Now you can evaluate the 1 million today and 1.2 million next year in two ways. Either you put the 1 million today to the future and you compare that 1.1 million you would have had you received the 1 million today with the 1.2 million opportunity. 1.2 is worth more than 1.1, so you'd rather take the 1.2 million next year instead. The next approach is to look at the present value. If you were going to have 1.2 million next year, it's equivalent to having 1.09 million this year. So you'd rather take the 1.09 million equivalents or the 1.2 million next year over the 1 million this year. Now, this is the essence of discounted cash flow analysis. We're equally happy with 1 million today or 1.1 million next year. And the process of moving cash today to the future is called compounding. Compounding because it increases in value. The process of taking the value in the future to today is called discounting. Discounting because it reduces value from 1.1 to 1. Either way, we say we're equally happy with 1 million today or 1.1 million next year because they have the same value. You could say present value or future value, but that's essentially the same, depending on which point in time you want to make that evaluation. Now, the same calculation can be repeated over many periods. The intuition is the same. And that's the basic time value of money calculation. The 1 million today becomes 1.1 million next year. That 1.1 million grows 1.1 times, become 1.21 million. And then finally, in the third year, the 1.21 million becomes 1.331. And instead of doing this math repeatedly, we notice that money increases 1.1 times every year, right? So instead of multiplying by 1.13 times, you could multiply by 1.1 raised to the power of 3. And that's a compounding process. We began with 1, we ended with 1.331. Now, the discounting process reverses the order. If we end up with 1.331, then we can discount it back and start with 1 instead. Remember, compounding increases in value. You can write this as a general formula like this. Future value equals the beginning present value multiplied by 1 plus the rate of return raised to the power of the compounding periods. The present value calculation discounts, so 1.331 is discounted to 1, and you can do that by dividing by 1.13 times, or you could divide by 1.31 raised to the power of 3 instead, and this gives rise to this general formula: present value equals the future value divided by 1 plus the rate raised to the power of how many periods you want to discount it by. That's the basic time value of money calculation, which allows you to move cash to different points in time as you will. Now, R is often called the discount rate because most of the time our calculation is going to be discounting. Remember, we invest today for the benefits in the future, so that means most of the calculations we're going to be doing involve translating future benefits and equate it to today so that we can compare that to the investment cost today you have to pay. So if the benefit of investing outweighs the cost of investing, you'd make that decision. The discount rate, where does that come from? Well, this is what we deserve. And we know in finance, high risk equals, that's right, thank you very much, high return. And we're going to learn later how to measure and quantify risk. But as we know, high risk equals high return. So an investment that has high uncertainty surrounding it, investors are going to value less because with higher risk, you require high return, and the present value calculation will reduce the present value of investment opportunities that have high discount rates. You may see different names for discount rate over the course of your study. They all mean the same thing. For example, required rate of return, that's from the perspective of the investor. I'm deploying my capital, so I need to get a rate of return that's commensurate with how much risk I'm taking on. That's from the investor perspective. The cost of capital comes from the entrepreneur's perspective. I am raising capital from investors. They have an expectation of how much they should deliver. So your expectation, my cost. Hurdle rate is another way to describe this is something you have to overcome. In other words, the rate of return you must clear in order to be profitable. So the essence is the same. And finally, the discount rate, which maps our activity that we did earlier. The discount rate reduces the value of future benefits to the present value by incorporating the risk requirement through the rate setting process. Now, dealing with multiple cash flow is simple. Just add them up one by one. Do the present value calculation each different pieces and then add them up. So if you have 10-year stream of cash flows, then do cash flow for each year separately and then add them all up. And that will give you the present value of your future cash flows. Now, we could do an example, perhaps installment loan. An installment loan is a loan that you spread the payment over time, usually in fixed amounts, but that's not always the case. Common examples, car loans, mortgages. So if you compute the present value of the installment that you have to pay to your lender at their required rate of return, that should reflect the original amount that you borrow from the bank in the first place. So let's do an example together. Suppose ABC Bank wants you to make a repayment of 50,000 baht per year at the end of each year for 5 years. And the interest rate that they want is 7% per year. The question is, how much did you borrow? The cash flow looks like this. Okay, you pay them 50,000 baht each year for 5 years. So if we calculate the present value of each of these pieces, we should get back the original amount that we owe the bank. So let's go over the spreadsheet and do this calculation together. The 50,000 per year cash flows are what you owe the bank, and the bank wants 7% in exchange for the money. So we could calculate the present value of all these 5 cash flows to see what the original loan balance was. Now let's calculate the present value of each of these. So the first cash flow, 50,000 baht, we're going to discount it using the discount rate of 7%. So that means we're going to divide by 1.07 raised to the power of 1. Now we don't need to have that power of 1, but I'm adding it here to remind ourselves that this is a present value of cash flow one step ahead. So we have to discount it one time. And this gives us 46,729. Okay, so we could do this for the second cash flow as well. So let me go on to another cell here and then calculate the present value of the next cash flow. Here we're going to discount with 1.07 raised to the power of 2 to represent the fact that this 50,000 is 2 years from now. And as you can see, the present value of the second 50,000 is lower than the first 50,000. We could repeat this calculation. So let me do this very quickly. And as we can see here, the present value of each of these cash flow declines as we move further out in time. And that's because, time value of money says the further out, the less valuable that cash is going to be for you. Now, all these 5 cash flow, once you do the present value calculation, in fact, you've moved them to the present. So their rightful position are actually not in year 1, year 2, year 3, year 4 anymore. Let me move them to where they belong, year 0. And if we sum them all up, we're going to get the present value of all these 5 cash flows, and that's 205,010 baht. That's how much you got from the bank, and then to repay the bank in full, you need to pay them 50,000 baht per year for the next 5 years, and that will be equivalent to the 205,000 baht they give you today. Now, we change the numbers. We could change the numbers. So if we change the repayment plan to 40,000 here and 45,000 here, you're going to see that the present value of the cash flow that you pay back is less than before. Because what that means simply is if you pay back to the bank less, the bank is not going to be willing to lend as much money out to you today. So your 205,000 is now down to 191,300 instead. One useful function of calculating the present value of all these is what Excel or any spreadsheet programs calls the NPV function. So let me type equal and NPV open parentheses. What this does essentially is it transforms the series of future cash flows, whichever series that you have at all, is going to transform that into the present value. So it asks for discount rate. So I'm going to put down 7%. And then it asks for the rest of the cash flows. So I'm going to put down the reference for the rest of the cash flows that we have in cell C2 up to cell G2, and then ask the spreadsheet to calculate. And it returns exactly the same calculation as our manual calculation on top. I could change the numbers here to 40,000 and 45,000 as before. And as you can see here, the output of this calculation reflects the revised present value calculation from before. So you could use this formula to calculate the present value of any stream of cash flows using just one simple line here. So I'll show you the formula in case you're interested in what this looks like. And this is how you calculate the present value of any stream of cash flows. Next, let's talk about investment evaluation. Now, if that rate of return, discount rate, hurdle rate, required rate of return, however you like to call it, is what you're supposed to earn, then are you actually earning more than you deserve in this investment opportunity? Suppose you're given, a stream of cash flow with a price attached to it. Is it worth paying for that investment opportunity or not? There are two approaches that people commonly use to evaluate financial decision makings, and that's the net present value and the internal rate of return. Now here I have the formula for you. Okay, they look a bit daunting, but let's go over the intuition in the calculations, and hopefully when we come back to this formula again, it'll make a little more sense. Okay, so let's consider a simple example. Suppose you want to invest in a condominium which is priced at 5 million baht. The current gross rental yield of 8%, you can expect to earn about 400,000 baht per year in rental income. Now, there are expenses associated with owning a condominium, for example, the common area management fees and so on. So let's say that's about another 100,000 baht. That means your annual income is going to be 400,000 minus 100,000, 300,000 baht per year. Now, and let's also say at the end of 3 years, you decide to sell the condo, which you expect to be able to sell for about 5.25 million baht. Now, in reality, you have to worry about fees, taxes, commissions, and so on, but let's not worry about that here and use the 5.25 million baht as the net proceeds you receive upon the sale of your condominium. So this gives you the cash flow for the next 3 years, okay, 300,000 baht per year for the net rental income and the 5.25 million baht at the end of year 3 for the sale of condominium. You combine all that together, you get the stream of the cash flows. Okay, so the first way to evaluate, remember our intuition. If your investment opportunity has lower price than the value, this is a good investment opportunity. So let's talk about the value. The value of this condo comes from your future rental income and the sale proceeds. So we have 3 numbers. 300,000 baht in year 1 and year 2, that's from your net rental income, and 5.55 million baht in year 3, which is a combination of your net rental income and the proceeds from the sale. If your rate of return that you want is 6% per year, you can use that to discount the value of future benefits, and this will give you 5.21 million baht value of future benefit. What's the price of the condo? The 5 million baht price tag. So if you compare the 5 million baht price tag to the value of the condo of 5.21 million, this is a good investment opportunity because value is greater than price. Now we can call this value minus price net present value, which reflects the net benefit, net inflow and outflows of your investment proceeds. And if this is greater than 0, it's a good deal. Now here's a place where you may find confusing. Why is 0 good? But remember, in our valuation, we embed the 6% requirements of return in the present value calculation. So if the net present value is greater than 0, it means the benefit you get from this investment opportunity already exceeds the 6% that you want. So we say the economic profit of investing in this condo is 0.21 million more than you want from this investment opportunity. Now, if that's confusing, I know it sounds confusing too, so let's try a different approach. Let's ask instead, I invest 5 million baht and I get 300,000 baht per year and so on. How much return am I getting on my original 5 million baht? So you can set up this equation. We'll come back to this equation later on in our formal class. But if you solve this equation where on the left-hand side is your investment, on the right-hand side is your benefit, and you get what the implied rate of return is, this is called the internal rate of return, and it measures your average rate of return per year on your investment capital of 5 million. The output here is 7.55%, and that's greater than 6%. So we're making a profit, right? We want 6%, we get more than what we want, so this is a good investment opportunity. Now, let's go over to spreadsheet and do this calculation together and look at the formulas required to reach this conclusion. But now, ladies and gentlemen, you already have the basic building blocks of financial valuation. So let's take the cash flows that we saw earlier and then use the spreadsheet function to calculate the net present value and also the internal rate of return. We could turn the positive cash flows from year 1 to year 3 and then turn that into the value of our investment opportunity. So let me type down value here, and we want to calculate the present value of these 3 numbers. We used the NPV function earlier. We're going to use the NPV function here again to calculate the present value of all these 3 numbers using the discount rate of 6%, or we also use the word required return to represent the same number. NPV, discount rate of 6%, which is referenced in cell B3, and then the cash flow from year 1 to year 3 referenced in cell C2 up to E2. This calculation returns the value of this investment opportunity, which lines up with our earlier example in the sheet of 5.21 million. The price of this investment opportunity, of course, is the 5 million that you pay for the condominium. So the net present value of this investment opportunity, which essentially is value minus price, this is greater than 0. So what you get is worth more than what you want in terms of the 6% rate of return requirement that you put. So this is a good investment opportunity. Now, as mentioned earlier, the 0.21 can be misleading because here 0 means good, 0.21 actually means fantastic, but it doesn't come across that way, does it? So let's turn our evaluation to percentage returns instead, and that can be done through the IRR calculation, which stands for internal rate of return. The spreadsheet programs already has the internal rate of return built in, so you can specify the cash flows that you want. Here it asks for all the cash flows, which you also have to include the -5 investment cost and also the other subsequent positive cash flows you get as return. As you close this calculation, it will give you the rate of return. Now, let's unfold decimal places to see the numbers. And here we get 7.55%, like our example in the sheet. So if your IRR is greater than the discount rate, hurdle rate, cost of capital, if you will, then this is a good investment opportunity. The NPV and IRR calculations are the workhorse of financial decision making. So if you understand the logic here, then you're good to go. So now that you see the calculations in the spreadsheet, what does this leave us with? How do we apply this in real life decision making? Remember, if price less than value is a good investment opportunity, you can replace the cash flows with other investment opportunities you may be faced with. For example, this could be a stock. The cash flows you receive could be dividends. I am valuing the dividend stream in the future. If the value of the dividend stream is greater than the price the stock is selling at today, that's a good investment opportunity. I could be doing this based on bonds, and the cash flows I'll be putting in would be the coupon payments that the bond promises to make and the par value that you get upon redeeming the bond certificate. This could be a piece of land, it could be a rental income I get from this piece of land, or it could be the profit that I get from developing a condominium on this piece of land. It could be an acquisition of another company. So this could be the cash flow that I get after owning that company compared to the price I have to pay. As you can see here, this very simple decision-making framework allows us to arrive at very, very useful conclusions that could be applied in many settings in real life.